Hello again. I am Brendan, and we are moving into Chapter 6. This is a big one. We are talking about the keys to the kingdom. Archird is going to explain why shared passwords are a disaster waiting to happen, and how to build a system that even your security team will love. It is all about moving from trusting people to trusting the system. Let us join Archird for Chapter 6.
Chapter 6: Keeping Passwords and Access Safe. A password that everyone knows is a disaster waiting to happen. When one password becomes everyone's problem. At 11:47 p.m. on a Friday, a financial services company discovered that someone had modified firewall rules across their network, opening access to sensitive customer data systems. The changes were made using the Automation account, a shared password that their network automation systems use to make configuration changes. The security team needed to answer 3 urgent questions. Who made these changes? Were they authorized? Was this an attack or a mistake? They couldn't answer any of them. The log showed only that the Automation account had logged in and made changes. They had no way to determine which automation job had run, which person had triggered it, or whether it had proper approval. The shared password had been used by automation systems for 2 years. 15 engineers had accessed it at various points. 3 of those engineers no longer worked at the company. The incident investigation took 6 weeks. The company ultimately paid $2.3 million in regulatory fines for inadequate access controls and incomplete audit trails. They could never definitively determine whether the changes were malicious or accidental. This chapter explains how to manage passwords and access for automation systems so you always know exactly who did what, when, and under whose authority. Why shared passwords are dangerous. Most organizations start their automation journey by creating a single service account with a powerful password. They give this password to every engineer who needs to run a script. In a professional architecture, this is unacceptable for 3 reasons. 0 accountability. If everyone uses the same key, you can never prove who opened the door. The leaving engineer problem. When an engineer leaves the company, you have to change the password on every single piece of equipment. Because this is hard and risky, most companies just don't do it, leaving a massive security hole. No limit to the damage. A shared automation password usually has God mode access. If that password is stolen, the attacker can destroy the entire network in seconds. The solution: the secret vault and unique identities. A safe automation architecture never stores passwords in a text file or script. Instead, it uses a secret vault, like HashiCorp Vault, Azure Key Vault, or CyberArk. Here is how a professional system handles access. The vault. All passwords are stored in a central, encrypted digital safe. The Automation ID. Every specific automation task has its own unique identity. It doesn't use a human password. Just-in-time access. When the automation needs to make a change, it asks the vault for a password. The vault gives it a temporary password that only works for that specific task and expires as soon as the job is finished. The digital signature. Because the vault knows exactly which job requested the password, it creates an audit trail. Now we know that job number 452, triggered by Sarah, approved by Mike, used this password at 2 p.m. Takeaway: stop managing passwords, start managing identities. What you need to believe. If you implement one thing from this chapter, stop using shared passwords and implement unique identities per automation function, managed through a dedicated password vault. This single change addresses the majority of password-related security problems and satisfies most regulatory requirements for access control. Hard rules to take forward. Never store passwords in code or local files. Credentials must be fetched from a secure vault at runtime. Hard-coded secrets are a primary target for attackers and an automatic audit failure. Unique identities are mandatory. Automation must use unique service accounts that are distinct from human accounts. Shared accounts create unidentifiable risk and complicate revocation. Enforce separation of duties through technical controls, not policies. Multiple people must be involved in critical changes, enforced by systems that make single-person control impossible, not just forbidden. Audit trails must be complete and immediately searchable. Minimal logging that requires manual investigation is inadequate. Each event must include complete context, enabling full understanding without correlating across multiple systems. Limit permissions to minimum required for specific functions. Each password should have precisely the access needed for its specific automation job, and nothing more. Calculate and document acceptable risk if passwords are compromised. The investment in proper password and access management seems excessive when building your first automation. The value becomes obvious when facing your first security incident, your first audit, or your first investigation trying to determine what happened 6 months ago. By then, retrofitting proper controls is expensive and disruptive. Building them correctly from the start is cheaper in the long run and prevents disasters that proper controls would have avoided entirely.
Security is not something you bolt on at the end. It is a fundamental part of the architecture. If your security team is currently blocking your automation projects, it is probably because they do not see this kind of structure. When you can prove exactly who did what, and show that passwords are never shared, you turn the security team from a roadblock into a partner. In the next chapter, we are going to look at using programming to catch mistakes before they ever reach the network. I will see you there.